Hey, welcome back from spring break. Hopefully everything went well and you are feeling well and everybody's healthy. I'm going to go over a couple things here before we enter into the next lesson. Hopefully you got to this video, but to kind of help you out, go to pre-calc is going to be under the calendar and the modules. And if I go to modules here, and one thing I'm going to try to do for most cases and for this video as well, post some guided notes. Some of them are a little more detailed than others. Some of them are just a copy of the class notes, the PDF that I have here. So it'll say 7-1, day 2 guided notes. The video's not up yet. It will be when you access this. And then I would suggest that you print these off. They don't have to be, but just to kind of keep things a little bit more organized. Now, these are not the formal guided notes, but these are just kind of the printed off slides to kind of help you keep everything together so you don't have to write as much down. But pause the video, print those out, and then come back, and then we will start section 7-1, day 2. All right, and again, before I get started with the lesson, a couple things here about the schedule. Since we're a CCP class, we're going to have to do a little bit more than what's listed on the class schedule on Monday, and we'll see how this first week goes and then see where we're at. Technically, we could be back in school next week. I don't see that happening, but we'll see what happens here. All right, today we're going to do section 7-1, finish that up. Assignment will be due by Tuesday. I'll be on Canvas Conference from 1 to 2, optional homework help. And on the Tuesday time slot, I will be on the conference from 8 to 8:30. I will be covering 2 or 3 problems from section 7-1 that I anticipate you to have problems with, or just to kind of review. This will be a live session, not a recorded one, and then you can also ask questions. I suggest you tune in. It's not absolutely mandatory, but I will be covering some of the problems that you will see on quizzes and tests, as well as answer homework questions. Probably about 10 to 15 minute lesson. Wednesday will be another posted assignment. Again, 1 to 2 optional homework help. Thursday will be similar to Tuesday, is that from 8 to 8:30, I will be covering 2 or 3 problems from section 7-2, kind of reviewing through things. Friday, there will be a review sheet over 7-1, 7-2. There will be no video notes. And lastly, we were going to, if everything goes right, we're going to look for a quiz over section 7-1 and 7-2 Monday. So there's a lot going on in these 2 sections with law of sines and then law of cosines. So that is the goal. Review sheet Friday, quiz, and as we get closer to Monday, we'll talk a little bit more about the details of how that will work. All right, I am going to turn myself off, and then we're going to do the lesson for today. All right. We are still in section 7-1. This is called, we already did the first part. This is the second part where we talk about what's called the ambiguous case. Ambiguous kind of means more than one thing can happen. And this happens when we have a side-side angle situation. Okay. For a side-side angle, let's say we know angle A, we know its measurement. It could be, and I'm just going to make up some numbers for a second here. It could be 50 degrees. We know side B, it could be 12 inches. We know side A, it could be 15 inches. We know 3 measurements. You need at least 3 measurements to solve. This is a candidate for law of sines because we know this angle, the side across from it, we know this side, and we can figure out what this angle is using the law of sines. Okay, so this is a candidate for law of sines. But we run into some issues in this case. Now, I'm going to get rid of these measurements because we're not concerned with what they measure. We just know we have those cases, side angle. Because here's what can happen. Ambiguous, we can either get 0, 1, or 2 different triangles. I can get a situation where there's 0 triangles given those numbers, there's 1 triangle, or there's 2 triangles. It will be based upon what those values are. The 2 triangles is the one that causes the most issues. Okay, here's what can happen. This length right here is the exact same as A. They are equivalent, okay, as you can see here. If I flip this and I can put it here, I can create a second triangle that has the same measurements as the first in those 3 areas. This length right here is the exact same as this length. So here's what I got. I got these 2 distinct triangles where this is angle A is equivalent to this angle. This is side B is equivalent to this side, and this side A is equivalent to this side. That's why you can never use side-side angle, or you could never use side-side angle to prove 2 triangles congruent in geometry, because they could be 2 separate triangles. All right, now here's a big part of this that we got to watch. This angle right here, that is angle B. That is going to be, so that is right here. Those are the same. Well, this angle here will be related to that one. They can't be the same, but will be related. Well, if you remember from geometry, if this side and this side are the same, then the angles across from them are the same. So that means this angle B would have to be the same as this angle. Well, what does that make this angle right here? That makes that angle 180 minus angle B. Because this angle and this angle are the same, if I take 180 minus it, that's what it left here. So if I look at these 2 triangles, all right, angle B is right here. That means this angle right here is going to be 180 minus whatever that angle is. And that's going to be important to solve for that second triangle. All right, hopefully you can see how you can create 2 separate, distinct triangles, yet they have these 3 measurements all the same. This is why we call it the ambiguous case, because more than one thing can happen. We also can come up with a scenario based upon the numbers where there's only 1 triangle or there's only 0 triangles. Okay. It will be based a little bit on the height as well, and we'll get into that here on the next slide. Okay, hopefully you printed off those guided notes. So you have an angle. Now, a lot of times you'll be just given this information and you won't have a picture. If you printed off the notes, obviously you have a picture. When you draw this, if you only have one angle, I would always suggest, just because it's easier for me and it's probably easier overall, if you put that angle in the bottom left corner to organize things just visually to understand those. So I'm going to put, since I know angle A, I'm going to put that in the bottom left corner. That is 50 degrees. Okay. Side A is 8 inches. That has to be across from angle A. So that is 8 inches. Okay, now theoretically, you could let B or C be this one. I like to know this side across from the angle and then this side here. So I would make this angle B and I would make this angle C, since I know side B. It's just a little bit easier because since we explained it this way by taking this side and kind of swinging this side to the here, it's a little bit easier to visualize when I know this side, and this angle. Doesn't mean you have to do it this way, but I guarantee you it'll be a little bit easier on the visualizing. All right, I got enough information here. I can use the law of sines. I can say sine of angle A over side A is equal to sine of angle B over side B. Okay. Now I don't know angle C and I don't know side C, so I can't do anything with those at this point. Now, everything we've done in section 7.1 of the law of sines, we found a side. This is the first time where we found an angle. Slightly different, but let's go through here. All right, angle A is 50 degrees, so this will become sine of 50 over 8, which is side A, equals sine of angle B over side B, which is 15. Well, this is a problem where you just got to cross multiply here. 8 times sine of B is equal to 15 times sine of 50 degrees. Divide by 8, divide by 8. And we get sine of B equals 15 times sine of 50 over 8. All right, when you are looking for an angle, you have to use inverse trig. So angle B is equal to the inverse sine of whatever that value is, 15 times sine of 50 degrees divided by 8. You cannot hit sine, you have to hit inverse sine to get the angle. So it's 15, I'm going to do the inside part, 15 times sine of 50. Make sure you close that, divided by 8. All right, now I'm going to hit inverse sine of the answer. And in this case here, it gives us an error. When that happens, that means there are no triangles that could be satisfied by the given conditions. So you just can't make up numbers and it will always give you a triangle. Because here's what's happened. If you look, I just kind of drew this out, but if you think about it, this doesn't make sense. If this is a length of 15 and this is a length of 8, 8 would have to be a lot longer. Because here's really what's happening in this situation. Is that is a length of 8, and if you have a length of 8 on that side, it does not connect to the other side. This is 50 degrees. That angle cannot change. This would have to be a longer length for it to connect. So basically, this is why we have 0 triangles. Those 3 measurements, 15, 8, and 50 degrees, will not yield a triangle. Okay, it will not connect to that opposite side. You'll get an error message when you do your inverse sine, and you are stuck. Okay, no triangles exist under those conditions. Okay, so that value here, this for side A, has to be big enough so that it connects at some point to the side across from it. So in this case, there's no triangles. All right, now on the next two, if you look at the guided notes, you will see where it says triangle 1 and triangle 2. If we do have a triangle, we're going to assume that there are 2 and kind of use those and kind of go from there. All right, again, based upon my conditions, if I only know one angle, I'm going to put that in the bottom left. I'm going to make that 40 degrees. I know the side across from it is 20. Now you have an option of putting A here or here. I'm always going to suggest that you put the other side right here. So I got side to side angle. So that means I want to make angle A the bottom right one. I want to make B the top one. You can do it the other ways. I'm telling you though, this is just easiest overall for visualization. So I got 15 here. I got 20. I got C is 20. That is 40 degrees. I can use law of sines to find angle A. So I'm going to set this up. Sine of angle A over 15 equals sine of 40 degrees over 20. Okay, just like the last time, I'm going to solve it. I'm going to cross multiply 20 times the sine of A equals 15 times the sine of 40 degrees. Divide by 20, divide by 20, and I get sine of A equals 15 times sine of 40 degrees divided by 20. Okay, we'll go here. That means angle A equals the inverse sine of whatever that is, 15 times sine of 40 divided by, that should be a 20. Okay. All right, using your calculator. Then what do I get? Now, let me move this over. I'm going to do the inside part. 15 times sine of 40 divided by 20 equals, and then I'm going to do inverse sine of the answer, 28. I'm going to round everything to the nearest 10. 28.8. Okay, 28.8 degrees. All right, we know already that angle C is 40 degrees. That's never going to change. We know that side C is 20, and we know that side A is 15. If we get an answer, we're automatically going to assume there's two triangles. That's the easiest way to do this. So in the second triangle, those measurements of 40 degrees, 15 for side A, and 20 for side C all have to be the same. Well, angle A, whatever our first angle is, I'm going to put that in for the triangle number 1, 28.8 degrees. All right, now here's how this works. Here's how the second triangle comes into play. Let me see something here. Because this side could flip over to this side here and create a second triangle. It's right here right now, but there could be a second triangle where that is flipped. Now we said there was a relationship between the angle. Let me go back and talk about that. In your two triangles, whatever, now you got to kind of ignore what the letters are at this point because they're immaterial. This angle right here and this angle right here are going to be related. Whatever this first angle is you find, the second triangle will have 180 minus that angle. Okay, because we drew it up here. When you flip that side, okay, when you flip this side over here and you create that second triangle, the inside angle is going to be 180 minus angle B. So go back to our problem. That means it doesn't matter about letters. Whatever angle you found first, since I find angle A first, I go over to the other triangle. And that means that this angle right here is going to be 180 minus 28.8. Don't start filling in the other values yet. To go over the second triangle, figure out what that is. So what's 180 minus 28.8? 180 minus 28.8 is equal to 151.2. So that's 151.2. At this point, we determine whether we have one or two triangles. Here's how. You know the three angles of a triangle have to have the 180. Well, if we said this one's 151.2 and this one's 40, they add up to 190. At that point right there, that means that that second triangle doesn't exist. So you cannot flip that over and still maintain those values and get a second triangle. It wouldn't exist. It only give us one triangle. But now we still got to find angle B, and we still got to find side B. Now that I know that this angle A is 28.8 degrees. Okay, I would always start out, if you have a side-side angle case and you get an answer here, assume there's two triangles, and you always have to take that first angle. In this case, it's angle A, and take 180 minus that. All right, we still need to find angle B. Well, that's just going to be 180 minus 40 degrees minus 28.8, and that gives me 111.2. So that is 111.2 degrees. Well, you can see I didn't draw this to scale because that angle is clearly not 111 degrees. Okay, it looks like it's a little bit less than 90. But we can still find the measurements. So I got to find side B. Well, I'm going to have to use angle B to find side B. Even though it's a rounded off value, you got no options. I would avoid using the 28.8 because it's rounded off. use the ones that we know are exact, which are the 40 degrees and the 20. So I'm going to take the sine of 40 degrees over 20. Sine of angle C over side C is equal to the sine of 111.2 over B. Now I'm looking for the side. This is back to the same thing we did the other day. B times the sine of 40 degrees equals 20 times the sine of 111.2 divided by the sine of 40 degrees. We do not use inverse sine because we are looking for a side. So I would just type in 20 times sine 111.2 divided by sine of 40 degrees. Okay, using 29.008, which is just 29.0. Now the side across from the largest angle should be the largest side. That is the largest side. And so it kind of makes sense proportionally. All right, only one triangle in this case, because after we find the first angle, which was 28.8, we do 180 minus that to get this angle here. If these two add up to more than 180, only one triangle. Okay. Now, these are all side-side angles. That's the only time we get what's called the ambiguous case. We can get more than one option. And then we got to figure out what the situation is. First case, 0 triangles. You get undefined, you get an error message. Second case, I get an answer, I test it, and the second triangle doesn't work. Well, third case, all right, probably going to figure this out. This is going to have 2 triangles. Again, depending on what you're given, if I'm given one angle, I am always putting it in the bottom left-hand corner. I know the side across from it is 11, and then C is 13. So I really have the option of putting it here or here if I haven't marked my angles. I like to have it where I know this side, and that angle. It's just easier to kind of wrap my head around. All right, in this situation, what angle can I find? I can find angle C. All right, let's do that. So sine of C over 13 equals sine of 47 over 11. Cross multiply, 11 times sine of C is equal to 13 times sine of 47 divided by 11. So sine of C equals 13 sine of 47 degrees over 11. Angle C is going to equal the inverse sine of that, 13 times sine of 47 over 11. So what do we get for angle C? And let me move this out of the way. Oops. 13 times sine 47 divided by 11. All right, hopefully you recognize if that number's less than 1, we're going to get an answer because we're doing inverse sine. If it's more than 1, that's where we get the error message. Inverse sine of the answer is 59.8 degrees. All right, if I get an answer, I am automatically going to set up this table and assume there are 2 triangles until proven otherwise. Put your given information that we already know in both of them. We know angle A is 47 degrees. We know angle A is 47. Side A is 11. And side C is 13. Your first angle, whatever it is to automatically triangle 1. 59.8. Before you do anything else, go to your second triangle, and that same angle, angle C, has to be 180 minus 59.8 every time. So I take 180 minus 59.8, and I get 120.2. At this point, I can determine whether there are two triangles or not. If 47 plus 120.2 is less than 180, I have a second triangle. And since it is, I can now figure that out. So I can find angle B for both of these before I do anything else. So this angle, so 47 plus 120.2 equals that. If I subtract 180, it gives me a negative. It's going to be 12.8 degrees. And I want to make this blue. For anything's given, I'm going to keep one color, and anything I figure out, I'm going to keep it the other color. What I say, 12.8. So that's 12.8 degrees. And now I'm going to go over to triangle 1. That's obviously going to work. I got 47 plus 59.8. Okay, and then I take 180 minus that. And I end up with 73.2. So 73.2. All right, now I'm going to go up here. And I don't know if yours is already uncovered or not, but I'm going to take this away. This is my second triangle. Okay, in it, I was already given this has to be 47 degrees. That cannot change. This has to be 13, and this has to be 11. Because what happened was this basically that arm, this side, whoops, hold on, swung over here. So that's how I get that second triangle. All right, what did I find for my angles? So I found 59.8, and I found 73.2. And then the other one was 12.8 and 120.2. So this right there, whoops, this is 120.2. This is 12.8. So these triangles do not look anything alike, but yet they still have the same measurements of 47, 13, 11. The other three are going to have to be different. Well, now you got to find side B for both of them, and it is just a separate problem. Use what we already know, and you want to use as few as rounded off values as you can. So I want to use the sine of 47 degrees over 11 equals the sine of 73.2 over B. And then I'm going to set this one up as well. So I want to use this one and this one. Sine of 47 degrees over 11 equals the sine of 12.8 over B. Solving those, B times the sine of 47 equals 11 times the sine of 73.2, divide by the sine of 47, and B equals 11 times the sine 73.2 divided by sine of 47. 14.4. All right, same thing here. B times the sine of 47 degrees equals 11 times the sine of 12.8 divided by the sine of 47. And I get B equals, what do I get? 11 times sine 12.8 divided by sine 47, 3.3. 14.4 and 3.3. Now you got to list both triangles when there's two of them. 14.4, 3.3. And everything kind of makes sense as a 12.8 degree angle, side across from it, the way this triangle, it has to be much smaller than the 14.4. 120.2 is the largest angle right here. That means the 13 in this triangle is the largest side. So you get two distinct triangles for side-side angle. This is the only time this happens. If you are given angle, side, angle, if you are given angle, angle, side, you will only get one triangle. You only have to find one triangle. The only time you worry about 0, 1, or 2 triangles if it's a side angle case. So you're going to have to sit down and look at it when you draw it out. If you just start solving things, you will end up getting problems incorrect. All right, let's see here. All right, this is your homework. Do not do 92. I meant to get rid of that one. So I need to take that off. Do not do 92. 6 problems. First 2 are similar, second 2 are similar, third pair are similar. There's the answers to the evens, so you know whether you're doing them right. Depending on how you do things, you could be off by a decimal point or 2 if you accidentally use values that were rounded off, other than the only one you have to use. All right, that's section 7.1. So this is Monday. This will be Tuesday, due Tuesday by midnight. Obviously, the earlier you get it done, the better. And then we're going to start following this format here for this first week, see what happens, and then make adjustments as needed. But Tuesday, I'll be on Canvas Conference from 8 to 8:30. I'll be doing about a, 10 to 15 minute lesson over some problems that are unique or not ones we've already covered. And then there'll be time for questions. There'll be time for questions from 12 to 2 if you get a chance, or 1 to 2 if you look at it ahead of time. Okay. And then same kind of format Wednesday, Thursday. Friday will be a little bit of a review day, kind of on your own. I'll post that. And then Monday, there'll be a quiz, basically a review sheet. Hopefully this makes sense. Send me an email. If it doesn't, that would be fine. I'm going to shut the recording down, and then hopefully you had a good spring break.